Section 2.6, Two Quantitative Variables, Linear Regression, Video 1. If you haven't done so already, you should probably go read the module for Section 2.2 about scatter plots and regression. And we are picking up where that section left off. So let's start with an example, and this example actually comes right out of the book. If you have your book with you, this is on page 124. Where we have a scatter plot representing some bivariate data, where the data recorded was the bill at a restaurant and the tip amount left by the customer. And you might be thinking, well, that's sort of linear, seems to have a positive association because of the upward trend. But what's this about a line of best fit, a least squares line, a linear regression, if you will? Well, we'll talk about the line itself in a moment. In fact, we'll go ahead and talk about it right now. Now, if you have the actual data set, you can use technology to come up with an equation of a line that will best fit this. And we'll talk about what it means for a line to best fit in a moment. But if I were to just kind of freehand this based on what I see on page 124, it kind of goes a little something like this. Not quite sure if it hits that point. Actually, there's another point way up here. But anyway, you got this quote-unquote line of best fit, or least squares line, or regression. And we'll talk about what that means in a minute. But let's talk about what we can infer just from this scatter plot. Let's say that we had this scatter plot and the line of best fit that goes with it. And we were to ask a question like, what estimated tip would there be for $60? So for a $60 bill, estimate the tip. Well, if we had this visual, then we could just take advantage of the graph by going over to the $60 on the horizontal axis, and then going up to the line, and then going horizontally from there over to the vertical axis to see where about it would land. Now, needless to say, this picture is not drawn as accurately as the one on page 124. So if you're looking in your book, you may have a different answer than I do. So if we go over to $60 and up to the line, then the line predicts that we're going to have about an $11 tip. Is that a good tip? That's a little under 20%, so it's not too shabby. Now, we could come up with some more questions if we knew what the equation of that line was. And we can actually come up with the equation of the line using a little bit of calculus. Of course, this is in a calculus class, so we would relegate it to technology. I take that back. There is a way to take all of these ordered pairs, do some arithmetic, and come up with the equation of this line. But the equation of this particular line, and again, I'm just stealing this straight from the book, is tip. The predicted tip is equal to negative 0.292 plus 0.182 times the bill. And I just stole this off of page 125, and if you look at that equation, you'll notice that there's a hat over the tip, like p hat, except tip hat. So what does that hat mean? Well, there's a couple of ways to interpret that hat. One way is to interpret it as the expected tip. The other way is to interpret it as the average tip for all bills of a certain value. For example, let's say we use this equation and we put in the 60 where the bill is. Well, if we put the 60 where the bill is, then we would have an expected tip or a predicted tip of negative 0.292 plus 0.182 times 60. And if we get out a calculator, although technically speaking this arithmetic could be done by hand, but I'm not going to waste our time doing that. Of course, it would help if I could press the buttons on the calculator correctly. And we get 10 to the nearest cent, $10.63. So I wasn't too far off when I said 11, so I guess my picture is drawn pretty well. But what does that $10.63 actually mean? What that means is, on average, the tip for a $60 bill is predicted to be $10.63. Now, believe it or not, there's a margin of error and a confidence interval associated with this, but we'll get to that when we get back to chapters 9 and 10.